Let's solve this integral here. As you can see, this integral contains the 6 trigonometry identities: sine, cosine, tangent, secant, cosecant, and cotangent. When you are given a trigonometry integral, you may want to rewrite the trigonometry identity and simplify it to something easier to integrate if you can. Now let's see if we can do that. Let's look at the numerator first. We see that it has a secant x, tangent x, and tangent x. And here, cosecant square x, cotangent square x, cosecant square x, cotangent square x. Looks like we can factor by grouping. Let's see if we can do that. Equals to integral. Let's try that. This is secant x times cosecant square x minus cotangent square x. Now plus here, let's factor out the tangent x here. Tangent x times cosecant square x minus cotangent square x. Okay, now divide by here, secant square x minus. Now we know that sine square x plus cosine square x is 1. So minus, then we can put a bracket here. This will plus. Minus sine square x plus cosine square x. Now dx. Okay, let's look at this integral here. Over here, what do we know? What is cosecant square x minus cotangent square x? Let's look at it here. Cosecant square x minus cotangent square x. We know that cosecant square x is 1 over sine square x minus cotangent square x is cosine square x over sine square x. Since the denominator is the same, so we can just combine this. 1 minus cosine square x divided by sine square x. 1 minus cosine square x is sine square x. Now over sine square x. That is equal to 1. Okay, nice. Come back here. The bracket is equal to 1 here. Okay, so that's equal to integral secant x times 1. So that's 1 plus tangent x times 1. Or divide by here. Sine square x plus cosine square x is 1. So that's equal to secant square x minus 1 dx. Okay, now equal to integral. Now secant x times 1 is secant x plus tangent x times 1 is tangent x. What is secant square x minus 1? Now we know that 1 plus tangent square x is equal to secant square x. Then you subtract 1 from both sides. You have tangent square x equals to secant square x minus 1. So that is equal to tangent square x. Now dx. Okay, now this integral looks like something easy to integrate. The next thing I will do is I will divide this into 2 fractions. So integral secant x divided by tangent square x plus tangent x divided by tangent square x dx. Now I can separate this into 2 integrals. So integral of secant x divided by tangent square x dx plus integral of tangent x divided by tangent square x dx. Okay, can I simplify this further? Yes, we can. Look at the first one first. Secant x over tangent square x. So here, secant x divided by tangent square x, that's equal to 1 over cosine x divided by sine square x over cosine square x. And that's equal to 1 over cosine x times the inverse of this, cosine square x over sine square x. Now, one of the cosine here cancel out with this cosine here. We have cosine x over sine square x. Okay, so that is equal to secant x over tangent square x. Equals to integral cosine x over sine square x dx. Okay, how about this one? Tangent x over tangent square x. Tangent x over tangent square x. Okay, so one of the tangent x cancel out with the tangent x here. You have 1 over tangent x. That's equal to cosine x. Okay. Let me write it out. 1 over sine x over cosine x. Like that, right? And that's equal to cosine x over sine x. Okay, now that's equal to cosine x over sine x dx, right? Integral. Okay, so now, are these two integrals easy to integrate? Yes, they are, because sine and cosine pair well with each other. Okay, so now what do? They are very similar. We can use U substitution on both integrals. What do? We will let U equals to sine x. du over dx is equal to cosine of x. And of course, du is equal to cosine x dx. So we can replace this and this with du. Okay, so now this is equal to integral 1 over. Now, sine square x, we let u equals to sine x, so this will be u squared. Du plus integral of, here, this one. So this is u, so 1 over u, du. Okay, let's integrate this. Okay, we can see this as, right, integral of 1 over u square du. That's the same as integral of u to the negative 2 du, right? So you add 1 to the power divided by the new power. And that is negative u to the power of negative 1. So that is negative 1 over u. Plus, what's the integral of 1 over u? Will be ln of u. Okay, now we said u is equal to sine x. Let's replace u with sine x. And I usually would like to write the positive term in the front and move the negative term to the back. That's equal to ln of sine x minus 1 over sine x. Are we done? Yes, we're done. So we can SC at the back. So this is the integral, or this is the answer for this trigonometry integral here. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.